Section 14.3, strengths of acids and bases. Do not think pH. We're not talking about pH here. What we're talking about is the same idea as electrolytes. Okay? So whenever we talk about a strong acid, what we mean is an acid that dissociates completely. And whenever we talk about a weak acid, and this is true for bases as well, a weak acid does not dissociate completely. Okay? It dissociates, it has to dissociate, because that's what an acid does. It gives off a hydrogen ion, but it just doesn't dissociate that much. Okay? Now, there are 6 common strong acids. You need to memorize these. All right? Element names and symbols, polyatomic ions, these 6 common strong acids. If it's not one of these 6 common strong acids, it's a weak acid. Right? So let's look here. Right? Here is before dissociation, hydrogen iodide. Okay, hydroiodic acid, hydroiodic acid, I should say. And so after dissociation, notice it breaks up completely. We have no HI remaining. So that's a strong acid. Only ions. Okay, and you can see it there. Now here's HF. HF is a weak acid. So here's before dissociation. Here's after dissociation, hydrofluoric acid, pretty nasty stuff. You can see only a little bit of it breaks off. And again, we can see that the product side is a 1-to-1 ratio, just as we think it should be, because if we look at that, H plus F minus. Okay, two-way arrow because it is in equilibrium. We can see by the picture as well, mainly HF molecules. The HF molecule itself does not act like an acid. Only the molecules that break apart act like an acid. Okay? Now, there are such things as diprotic acids. What we're talking about here, also polyprotic, just basically acids that give off more than one hydrogen ion. So in this case, carbonic acid, which is found in soda. As soon as you open the soda, that carbonic acid breaks down, but we're not worried about that too much right now. So H2CO3, first it gives off one hydrogen ion, and hopefully you notice something. This is amphoteric, right? Because it can go on. This guy can go on to give off another hydrogen ion, or it can go backwards and gain a hydrogen ion. Okay, but diprotic acids lose their hydrogen ions stepwise. Polyprotic acids, they lose them stepwise. Usually the first step is a big one, so like it's fairly strong, and then the subsequent steps are weak. Okay. Now, we'll get into this more later, but the stronger the acid, the weaker the conjugate base. And likewise, the weaker the acid, the stronger the conjugate base. So let me make sure I said that right. The stronger the acid, the weaker the conjugate base. The weaker the acid, the stronger the conjugate base. I think I said that, but I just want to double check. Okay. Your strong acid, or your strong bases, are your hydroxides. So we talked about the strong acids, they dissociate completely. Your strong bases dissociate completely. Now, these are the group 1. Group 1 dissociate completely. Group 2, though, which are these guys, although the amount that dissolves dissociates completely, very little of it dissolves. So we may throw in 5 grams of strontium hydroxide, but that doesn't mean that 5 grams breaks up completely. A very minute amount of that strontium hydroxide will break up completely. Okay, but the amount that actually does dissolve breaks up completely. Weak bases are usually your NH3 and then any hydrocarbon with a NH something on them. And these are called amines. So your weak bases, NH3 and then amines. All right? Don't worry about that direction of the reaction. It's, we don't have to worry about it. This has been good. We should do this again.